Welcome back to this video series on the topic of expansion and empowerment. Chapter C, Expanding Perfect Squares and Difference of Two Squares Situations. In this lesson, you'll learn how to identify and expand perfect square and difference of two square situations. Starting off with perfect squares, a perfect square arises when an expression is multiplied by itself. If we observe this example down here, we have the expression a plus b, and it's multiplied by itself as shown by the squared symbol. A perfect square may be expanded by shorthand by first squaring the two terms and then adding double of the product of the two terms. What does that look like? Well, we start off by squaring the first two terms, so we'll go a squared plus, and I'll leave it blank for now, and then finish off with b squared. After which, we go by adding double of the product of the two terms. So the product being a times b, so it's double, so 2ab. And thus we arrive at our expanded form. So a plus b all squared is the same as writing a squared plus 2ab plus b squared. So this is the perfect square situation, and this is the shorthand of how we expand it. Let's have a look at putting this to use. Example 1. Expand the following expressions. We have x plus 2 all squared. What we're going to do is we're going to use the shorthand version of the perfect square expansion. So in this case, my a is x and my b is 2. So I start off and I go x, and that's going to be squared, plus double of the product, so 2 times x times 2, plus, and then I square the final term in the expression, so 2 here. So this is going to be x to the power of 2 plus 2 times x times 2 plus 2 to the power of 2. Taking or doing the multiplication, we get x squared plus 2 by 2 is 4, x, and then 2 squared is 4. And thus we expand our perfect square situation. Let's have another go. X, take 3, all squared. This one is different because we have the negative here, but it's carried out exactly the same as before. A in this case is going to be x, so it's x squared, plus twice of the product of the two terms, so 2x and minus 3 in brackets, plus in brackets minus 3. If I use the brackets like this, I won't accidentally reverse one of the negative symbols or forget it. Next, I'll do the actual multiplication, so that's x squared. I've got 2 by 3, which is 6, but one's negative, so it's minus 6. And then minus 3 times minus 3 is just 9. And thus we complete our second example in example 1. So the way in which we expand the perfect square is we square the two terms and then we multiply them together and multiply it by 2. So a plus b all squared is a squared plus 2ab plus b squared. When you become proficient, you can go from this step here all the way down to here. Okay, let's look at something a little bit different. Let's have a look at the difference of two squares situation. The difference of two squares situation, acronymed as DOTS, arises when two opposite terms are multiplied together. If we consider we have a plus b, a minus b. So they're opposite because you've got the plus and the minus. So we've got the same values, a and b, but we've got the opposite symbol or operation. The dot situation may be expanded by shorthand by negating the square of the second term from the square of the first. What does that look like? Well, the square of the first is just a squared. We negate it and we go b squared. So this is the shorthand way in which we expand the difference of two squares. Let's have a look at how we can put this to use. First example, we have expand the following expressions, x plus 2 multiplied by x take 2. Expanding this out, I identify my a as x and my b as 2. I notice that there's the opposite symbols, so this is dots or difference of two squares. Expanding this out, I simply square the a then subtract the square of the b, which in this case is 2. Finishing this off, it's x squared, take 4. So there we go. Shorthand expansion of dots. Next example, we have 2x plus 3 multiplied by 2x take 3. Again, this is the dot situation because we have the opposite symbols with the same values. Expanding this out, my a in this case is 2x, so I square it. I go minus, and my b in this case is the 3, so I square that. The next square, it's going to be 2 squared x squared, so I have to square each factor within the bracket, minus 3 squared. And then finishing this off, 2 squared is 4, x squared stays as x squared, and minus 3 squared. We have to pay particular attention because the square binds most closely to the 3, ignoring the negative here. Alright, let's have a look at something slightly trickier. Expand and simplify the following expressions. We have what's called a non-monic. This looks like a perfect square. And then we have another perfect square matched with a difference of 2 squares. Let's start off with A, or in this case E. We have 3, 2x, take 1, all squared. First thing we're going to do is we're going to ignore the 3 over there. And we're just going to focus on expanding the brackets here, which is a perfect square. So doing this, I'll go 3, and I'll put in some square brackets to emphasize I'm ignoring it. And then I'll go 2x squared. Now, because this is a perfect square, I have to go plus double of the product of the 2 terms. So 2x minus 1. And then finishing this off, it's the square of the b, so negative 1 all squared. Okay, next I need to actually do the multiplication, so I'll ignore the 3 still. 2 squared x squared plus 2 by minus 1 is minus 2 times 2 is 4 or minus 4. And then minus 1 squared is going to be 1. Okay, next step, we are going to clean up inside the brackets. 2 squared is 4, so it's 4x squared, minus 4x plus 1. And then we've got single brackets with 3 inside, 3 terms inside, so 3, 3, and 3, if it will reach. So that will be 3 4s are 12 x squared. 3 4s are 12, but it's minus, so it's minus 12x, and 3 1s are 3. And thus we arrive at our expanded form of this non-monic perfect square. Okay, next example, we have x minus 1 all squared plus x plus 2 times x minus 2. So we're dealing with an expression where we have a perfect square and we have a dots situation. So expanding this out, we can expand both as we traverse down the page. So perfect square, that's going to be, and I'll do it in brackets, it will be x squared, then plus 2x minus 1 plus minus 1 all squared. So that's our perfect. Next, we have our dots. I'll do that in brackets. The dots is going to be a squared, which is just the x, take, and then we've got the b squared, which is 2. So that's 2 squared. Actually carrying out the multiplication now. X squared, 2 1s are 2, and 1's negative, so it's minus 2x. Minus 1 squared is positive 1. That's our perfect. Next are dots. X squared minus 4. Okay, And it's at this point we don't actually need these brackets anymore, so we can say bye-bye to the brackets. And then we can collect our like terms. So looking at this, we have 2x squared, so 1, 2, so that will be 2x squared. We have just one linear term, so minus 2x. And then we've got two constants, plus 1, take 4. So 1 take 4 is minus 3. Demonstrating how we can expand multiple brackets using the shorthand versions of perfect and difference of two squares. So in summary, for this lesson we set out to learn how to expand perfect squares using the shorthand notation. That being, you square the two inner terms, so a squared and b squared, and then you add double of the product of the two, so it becomes a squared plus 2ab plus b squared, so that's perfect. And then we also had a look at difference of two squares, so in which case you just go a squared take b squared as shown over here.